loud. Okay. So 8.2, we're going to continue talking about angles and relationships. In this section, we have the angles as part of these figures called polygons. So polygons are this is just a general word for a closed figure with straight sides. Now, I am not super concerned that you memorize the names of different polygons. You probably know several of them, but everything we want to do with polygons in this section is based on how many sides. So, for instance, if I have a polygon with 3 sides, what's the specific name for a polygon with 3 sides? That's a triangle. Okay. Again, if you don't know the words for these, I'm not super concerned about the labels for these. I'm not going to give you the word octagon and have you know that it has 8 sides. There will be a picture. Some of the figures I'll just call an 8-sided figure because again, I'm not trying to torture you with just extra trivia. Okay, so if I have a 4-sided figure, well, a rectangle is a 4-sided figure with 90-degree angles. So you're right, this is a rectangle. What's special about a square? Okay, a square, I'm doing my best job to try. A square is a rectangle that has all sides equal. That's a square. But more generally, anything with 4 sides is called a quadrilateral. Quad, the prefix quad means 4. Yes, exactly. And then anything else with 4 sides would be a quadrilateral as well. So like it could be something like this. So I could do something like, okay, no relationship between the sides at all, but there's 4 of them, it's quadrilateral. Okay, so the only thing is, so polygons are labeled by the number of sides. Does anyone know what we call something with 5 sides? Pentagon, the prefix pent means 5. Hex is the prefix for 6, that's 6-sided. So like does a stop sign have 6 or 8? I don't know. I don't pay attention to stop signs. There you go. Another thing about the trickster that you didn't want to know. So octagon has 8 sides. So those would be like the most common ones. And if you happen to know the names of them, great. If you don't, I'm not super concerned. I'm not going to make a thing on the test about the names of the polygons. My favorite one is a 9-sided figure, which is called a nonagon. I just like to say it. I think it's fun. But here's what we want. Here's what we want to do. What's that? Oh, stop sign's 8. Okay, good. Stop signs 8. I think there is some sort of traffic sign that's a hexagon with 6 sides, but again, who knows? So here's what I want to do though. What are the sum of the interior angles of a polygon? There's really 2 or 3 things in this section that we are going to talk about. There's 3 things. We're going to talk about the sum of the angles. We're going to do some general angle fun problems, and then something about what's called similar figures. So there's 3 topics we're going to get to in section 8.2 that are relevant to your future. So this is the first one. You are going to help me in this. We are going to rely on probably a piece of trivia that I would say probably at least half of you know this. If I give you a triangle, does anyone remember what the 3 angles of a triangle add up to? Anyone remember that? 180. 180. Yeah, it's kind of, for whatever reason, I don't know why, that's somewhere that becomes common knowledge for most of us in some math class. Okay, so for a triangle with 3 sides, then the sum is 180 degrees. Remember, sum, let me define this just in case you're not familiar with the word. This word SUM, sum, means to add up. No, that's trigonometry. You don't need that. That's too detailed. We are doing a very general overview of things. I will tell you what about triangles you need to know. It has to do with their angles. Okay, but we'll get to that in just a minute. Okay, so 3 sides. Now let's do this. Let's say I have a quadrilateral. I'm going to draw a rectangle, but it could be any quadrilateral. So I've got a 4-sided figure. How many triangles? If I draw a line in here, how many triangles? Like this was a cake, and I want to just divide it up. How many triangles of cake could I make? 4? Well, okay, that was a really bad question. So let me just do this. I'm gonna show you what I mean. I'm gonna draw one diagonal. How many triangles do I have now? 2. Okay, so that's what I meant. Sorry, you were totally right, because no one's gonna eat like half a cake, right? Good job. So maybe I would though, with my soda. So who knows? Okay, so 4 sides. I can make 2 triangles. And here's the thing. This is the relationship. You're going to help me. We're going to do a little. Induction reasoning right here. If each of these triangles has 180 degrees, how many degrees are there in a 4-sided figure? I've got 180 degrees here, 180 degrees here. So that means total in my 4-sided figure, I have what? 360. Let's move it on to a hexagon, 5 sides. And here's my 5-sided figure. Pentagon, yes. See, don't even know what I'm talking about. You shouldn't even listen to me. Okay, so here is a pentagon, 5 sides. Okay, so I'm going to divide this up into triangles. Okay, so I've got 5 sides. I'm just going to use this. I'm going to use this vertex down here, and I'm going to go, okay, 1, whoop, like that. How many triangles was I able to divide my pentagon into? Okay, there's 1, 2, 3. So I've got 5 sides. I'm going to do one more, and then after this, and then you're going to help me with the relationship. I've got 5 sides. I'm able to cut this into 3 triangles. And so that means that how many degrees would there be in a pentagon? More than 360. So 360 plus another 180, that's 540 degrees. Yes. Okay, so here's the last one, and then we're going to come up with a general relationship because I don't expect you to memorize each of these things. So this time I will do a hexagon, 6 sides. I'm going to divide this up into triangles. So I'm going to use this vertex down here. 1, 2, 3. So I've got 6 sides. How many triangles was I able to divide up my 6-sided figure into? Okay, there's 1, 2, 3, 4. And because I don't have my calculator with me, each of these has 180 degrees. So that's 4 times 180 degrees, whatever that turns out to be, whatever the calculator says. Okay, so here's the bottom line. This is why I drew all these on the board, to see, can we follow the pattern? So I'm just going to summarize. When I had 3 sides, that is a triangle, 1 triangle, sum is 180 degrees. That's our given information. 4 sides, I was able to divide that into 2 triangles. So 4 sides became 2 triangles. 5 sides became 3 triangles. 6 sides became 4 triangles. If I drew a 7-sided figure on there, what would you guess? We went from 4 to 5 to 6 sides. We went from 2 to 3 to 4 triangles. So if I had 7 sides, I'm not going to draw it, but how many triangles do you think I could make on a 7-sided figure? 5. Because you're noticing, what's the relationship between the number of sides of my figure and the number of triangles I can cut it into? 2 less. Perfect. That's always the case. So this is how you figure out the sum of the interior angles of any figure. Okay, so the sum of the interior angles of a polygon is this. It's the number of sides, we're just going to call that n for number, minus 2 less, that's what you just told me, that's the relationship that we kind of see going down the line here. If I have 4 sides, 2 triangles, 5 sides, 3 triangles, 6 sides 4, 7, 5. So it's n, the number of sides minus 2 times, that's the number of triangles I can cut it into, so times 180 degrees. So here's what I would like you to do. You got your calculator or your phone calculator or whatever, you use your fingers, however you're going to do the multiplying. I want you to determine the sum of the angles of an 11-sided polygon. I'll give you a minute or two to chew on that. Sum of the angles of an 11-sided polygon. Bless you. Okay, so the sum of the angles of an 11-sided polygon, well, if I have 11 sides, that means I can cut it up into 11 minus 2 triangles by that relationship we just saw a minute ago. And then I'm going to take those 9 triangles, each of them has 180 degrees. So what is 9 times 180? 1,620, did I hear you correctly? Awesome, 1,620 degrees, perfect. Okay, well, that's a fine problem, but there's not anything super interesting about it. So let's make it a little more interesting because I want you guys to have a good time this morning. If I have what's called a regular polygon. A regular polygon means that all the sides and all the angles are equal. So I pretend that this is a regular octagon or a regular 8-sided figure. Again, I don't care if you remember the name of it or not. So even my drawing, even though that's maybe the best octagon I've ever drawn, it still is not perfect. So I will declare for you, I will tell you on the test that something is regular, don't assume. And so if that's a regular octagon, here's the problem that you are going to encounter. It's just a little bit of a problem-solving deal right here. What we're going to do is we're going to extend this side right here, and I want to know what is the value of this. That's x degrees. What's the value of that angle? Okay, it's a two-step problem that I have to get to. So here are the steps. I'm going to use what we know now about interior angles and the fact that it's a regular figure. I'm going to use that to figure out what this angle right here is. I'm going to kind of shade it black right here, different color, so you can see it. I'm going to use what I know about the interior angles to figure out this angle, and then we'll draw on our knowledge from last class to be able to figure out this relationship right here. Okay, so it's a two-step problem. So step number 1. Do this for me. We're going to go in steps. Step number 1. What is the sum of the angles of an octagon? Okay, same problem we just did, just different number of sides. What's the sum of the angles of an octagon? What's that?
I'm just asking if this is like it's when I left here.
You've finished it already? Okay, good. So everybody's calculating it. You're just ahead of the game. That's great. So the sum of the angles of the I'll give everybody another moment or two to come up with that, because I want you working through this, because this is exactly what your homework problem is going to look like. This is exactly what a test problem is going to look like, is doing this. How I'm going to see if you remember how to find the sum of the angles of a figure. So since I've got 8 sides, the sum is 8 minus 2, because that means I could divide this up into 6 triangles. Each of them has 180 degrees. And what did you say that was? 1080? Okay, great. So that means the sum of all these angles is at 1080 degrees. Now this next part you're going to do for me, we can do because it's regular. Regular means all the angles are the same. So if I have 1080 degrees here and all the angles are the same, how can I figure out what this one is right here? Divide, yes. So what you're going to do in step 2 is you're going to divide to figure out the one. So there are 8 angles, 1, 2, 3, 4, 5, 6, 7, 8. So you're going to take that 1080 degrees and you're going to divide it by 8. And what is 1080 divided by 8? 135? So that means this angle right here is 135 degrees. Now I just want to reiterate, the only reason we can do that is because I told you it was a regular octagon. If I didn't tell you that, then we'd have no way to figure out what each individual angle is. They have to be equal for me to divide it up. And then the last thing, since I drew this dotted line, how do these two angles relate? They're supplementary. So then take a moment. I'm going to give you a moment with your calculator to figure out what x is equal to. All right, and so you told me they were supplements. So 135 degrees, which is that angle we found, plus x, which is the one I don't know, have to equal 180. And so when you do that subtraction, that is how much? 45 degrees. Great job. So x, the angle we're looking for, was 45 degrees. Well done.
That's the answer every time for that question because they're all the same size.
Well, if I change the number of sides, it would be a different value.
Just for an octagon, if you ask that for a regular octagon, the answer is 45 every time.
If I ask this for a regular octagon, the answer would be 45. Yes, because once you know that it's regular, that locks in that these are going to all be the same. Yes. If I did not tell you it was a regular octagon, then we couldn't make any determination that because each angle could be a different measure, and that's what makes this an interesting problem. Okay, so in a moment, we're going to come to my favorite problem from the section, and we'll do a couple of them. But before we do this, I'm mentioning this because it's on the final exam. Okay, just the different kinds of triangles. You mentioned this earlier about different kinds of triangles. We had a book. This will just be in the book, but I know that not everybody looks at the ebook, so I'm going to do my best to draw these things out. There's 2 ways to categorize triangles. You can either categorize triangles by the way their sides are or by the way their angles are. That's the 2 ways to do it. So the first way, by their angles. An acute triangle. You remember last time we were talking about angles? I told you what about an acute angle? What's special about that? Less than 90. So in an acute triangle, all the angles are less than 90. So something like, I don't know, some generic, all these angles are less than 90. An obtuse triangle. Well, again, as you're writing this down, the word obtuse, when we used it in reference to an angle, what is an obtuse angle? Bigger than 90, but less than 180. Yes, it's bigger than 90. So an obtuse triangle has an obtuse angle. So something like, there you go, that's nice and obtuse. So an obtuse triangle has an angle that's more than 90. An acute triangle has all angles that all less than 90. And then the last type of triangle, if you're categorizing by angle, is a right triangle. And then again, if we're thinking back to what we already saw last time, a right triangle, what is a right angle? 90 degrees. So a right triangle has a right angle. Great. That's how you categorize triangles by angles. If you were doing it by sides, you could do this. We have what's called equilateral triangle. You see the word equi right here? Equi, what does that remind you of? What word that we use a lot in math does equi remind you of? Equivalent or equal, yeah. Starts out kind of the same. And so equilateral just means all the sides are equal. I don't know that I've necessarily captured that. And because of that, in math books or on math drawings, if somebody wants you to know that all the sides are equal, but maybe I was frightened that they don't draw well enough, what they'll do is they'll put like a little mark on each of the sides. That tells you that all the sides are equal. Okay, so there you go. I should have done that on the octagon a minute ago. Hey, this next word I can't spell. I should probably give bonus points. I think that's it. Yeah, isosceles triangle. Isosceles triangle just means two of the sides are equal, so I'll just put a mark on each. And last but not least, if none of the sides are equal, it's called a scaled triangle. Now people just gotta label everything. So it's surprisingly hard to draw a scaled triangle. That's gonna be good enough. I think all the sides are different lengths there, but there it is. All right, so with that in mind, we've got two things left. We've got a half hour, we've got plenty of time. We're doing great on time here. The thing number one, that these are my favorite problems from this unit, just because we get to use our brains a little bit, and it combines a lot of the different relationships that we've seen. I'm going to draw a figure on the board, and what we're going to do is we're going to figure out the missing angle. So here's our figure. Okay. So I've drawn three lines that intersect, and the key here is they form a triangle in the middle. We're going to use that fact to help us. We are told that this angle out here is going to be 37 degrees, and we're told that this angle right here is 132 degrees. I will give you a moment to catch up with me. I know that my fantastic drawing happens so quickly. And what we're going to be looking for, believe it or not, is we want to figure out what this angle right here is. This one down at the bottom. I'll put a little arc there just so we know which one we're talking about. I want to use the information that I've been given to figure out what that angle down at the bottom is. So we have lots of relationships we know now between different angles. We know the sum of the angles of a triangle. That was given information to us. So let's do this. Is there any angle that we know right away that we can figure out? Okay, we do know the vertical. I'm just gonna, and we can label that one, but that's not gonna be the most super helpful one. So the way we're going to approach this problem, so let me give you a little aid. I probably should have done this before I asked the question. What we're going to do is we're going to use this triangle as our reference point. So what I want to do, if I want to get down to X, I want to use this triangle as my way to get from up here to down here. Because if I get this angle right here, it doesn't really help me go anywhere. Okay, so it's a good thought. There is an angle that's vertical that would help me. This 37, I know this one's going to be 37, so I'm going to do it in red. So if you're watching on the video, I hope that comes through. Okay, 37 degrees. So now what we're doing is we're using this triangle as a reference point because we know a fact about the triangle, and that's going to help us get this out here at some point. Now, to your point, this 132-degree angle can be helpful to me. How can I, instead of the vertical, how can I use this 132-degree angle? I'm sorry? It's supplementary to this one, right? So this angle right here and the 132, they add up to 180 degrees. So what does that leave, if you got a calculator for me, what does that leave for right here? 48. Great. 48, if you're making notes for yourself, if you're like, where did that come from? 48 and 132 add up to 180 degrees. Okay, that helps me. We're almost there. We're almost to the finish line. We really only have 1.5 more steps to go. How can I figure out, since I've got these two angles of this triangle, how can I figure out this angle of the triangle right here? Yeah, triangle has, I'm going to write this down for you just to remind you because it's new for today. A triangle has 180 degrees. And so I'm going to take that 180 and I'm going to subtract 48. And then whatever that is, I'm going to then subtract the 37. And that's going to leave me what's left for the final angle. So 180 minus 48, I think that's 132. We just saw that. And when I subtract 37, I think that's going to be 95, but you might want to check. 85? 95? Math cage match? Made it? Oh, you did 48 plus 37 and got 85. Now subtract it from 180 because the triangle has 180 degrees.
Oh, I didn't get to that point yet.
Yeah, no, that's fine. You just went about it a different way. So it's totally a great way to do it. So we were just kind of answering different questions in that moment. So this angle right here is going to be 95. What she did, in case anybody didn't hear, instead of doing what I did and subtracting successively, she added these two right here and got 85, and then she still needed to subtract to get the 95. So that's where our wires were crossed a little bit. And now we are ready to finish the problem. What's X? A vertical angle. That is true. Great word, 95 degrees. So I like these problems because it allows us to incorporate several different things that we've talked about. So I'm going to give you one to do because I want you to sort through this. Again, remember the key bit of information here is that we are using the triangle in the middle as kind of our reference point that helps us tie all these angles together. So here's another one. And what we're going to do is this. I'm going to tell you that this angle out here is 30. I'm going to tell you that this one right here is 145. And then what we want is we're going to look for this one right out here. I'm going to put an arc. We're going to call that X. So again, you're using the triangle to form the relationship. Give it your best shot. Remember, even if you're wrong, we're learning. That's the goal. right, so on this figure right here, since this angle is 30 degrees, I can then say, what's this angle of the triangle? Okay, 30, great job. We're 1 for 1, love it. Since I'm told this is 145 degrees, what is this angle going to be? How did you get that? 35 is correct. Where did that come from? Okay, these two things are supplements. They form a straight line, so they add up to 180 degrees. So what you do on your calculator, you just say, okay, 180 degrees for the straight line, minus the 145 leaves me 35 degrees. Perfect. So then I need to figure out this angle up here. So the three angles of a triangle are always going to add up to what? 180. Okay, so I'm going to do this the other way. It's 35 and 30 is 65. So I'm going to come over here and I'm going to say, okay, my triangle is 180 degrees. I'm going to subtract the degrees I already know, which is 65. And that leaves me 115. Yeah. And then last but not least, the only difference on this problem than the previous one that I erased is that the last one we were looking for the vertical angle. This time we're not, we're looking for this. And so what's the last thing I have to do to find out what x is? Yeah, again, these two are going to add up to 180 degrees, and that turns out to be 65 degrees. Perfect. Wonderful job. Before I move on to the last thing for the day, any questions, comments, concerns, anything that I need to clear up that I haven't done a good job with? Yeah. Sure. A request. Love it. All right, so let's do this. All right, so let's see, we got this right. All right, so let's say on this one to try to make it, I mean, there's not a whole lot I can do since again, it's basically the same problem that we did before, but let's say that this one is going to be 17 degrees. Let's say that this one is going to be 150 degrees. And then I want to know what is this angle right here going to be x. Pretty similar to what we just did. Once you've done a couple of these, and I'm glad you asked for another, there's not a whole lot of variation after that. $150. Great question. I'm going to get started on this, and so check your work with mine. So again, the first thing you know, again, the triangle is the thing that links everything together. So I'm going to take the 17, and that's going to make this angle here 17 because it's vertical. This is 150. It's supplementary with this this angle of the triangle, so that is going to turn out to be 30 degrees. 30 and 17, that's 47. So inside the triangle, I've got 180 degrees minus the 47, that's 133. And then last but not least, that 133 and x, they are supplements, so they need to add up to 180 degrees. So that is 47 degrees is the value of x. Are you getting stumbled somewhere? Okay, this 47 or right here? Well, these two right here add up to 47. Okay. And so the three angles of any triangle, no matter what the shape, size, sides, angles, any of it, always adds up to 180. So we were able to figure out this one was 30. We're able to figure out that one is 17. And so then 30 and 17, I took these two things right here, and that gave me 47 degrees right there. And so this is my 180 degrees in the triangle. So 180 minus the 47 left me 133. So that has to be the big angle of the triangle. That's where that came from. All right. So if you want to stay after class, and I'll give you another one, and you can work through it, and I'll watch you. I'm totally fine with that. So we can get another one in. So the last thing for us today in section 8.2 is what's called similar figures. If you're told that two figures are similar, what that means is that the two figures have the same shape, meaning their angles are the same. So in similar figures, they have equal angles and the sides are in proportion. So similar figures, they have the same angles, meaning they have the same shape as each other, and their sides are in proportion. So I'm going to draw two. This is my best attempt to draw two similar pentagons. It's going to look like home plate in baseball, if you're familiar with that. So not the best home plate, but it's gonna have to suffice for our. So I've got that pentagon, A, B, C, D, E. Now what I'm going to do is I'm going to draw a bigger one. And I'm going to call this A with a prime, just so that we know that what the relationship is. Prime designates these as different things. Okay, that saves us letters. And I'm telling you that even though they don't look perfectly similar, that those two things are similar. Okay, that's given information. Okay, so you have to trust me in my poor drawing skills. I'm going to label a few sides. I'm going to tell you that side AB on the smaller pentagon is 4. Side BC is X. We don't know what it is. And then side CD is 3. On the other one, the top side, A prime, B prime, we're going to call that Y. We don't know what that is. The right side, QR, we're going to call, sorry, not QR, B prime, C prime, we're going to call 3. And then last but not least, we're going to make side, this last side, C prime, D prime is 4.5. So what we're going to be asked to do is we want to find the missing values. We want to find X and Y. So the instructions here are finding the missing values. Again, simple example. Simple doesn't mean easy. Simple just means fewer steps, but real useful skill if that you can use. I use finding proportions around the house quite a bit when I'm doing little projects. So this is not a bad thing to learn. Okay, so similar figures. When I have to figure out the missing information, I have to figure out X and I have to figure out Y. We're going to do it one at a time. I'm going to take on the challenge of figuring out X, then I'm going to let you take on the challenge of figuring out Y. Here's how you do this. The first thing that you have to identify is identify two sides that are in the same position on each figure that you know both of them. So is there a side on my two similar figures that I know both of the values? Okay, C and D or DC and C prime D prime. Does everyone see that these two sides right here are in corresponding positions and I know both those values? You tracking with me? Okay. So then what you do is you set up a ratio with those. Okay, so I'm going to say 3 goes with 4.5. Hey, Perkster, could I do 4.5 on top and 3 on the bottom? The answer is yes. Okay, absolutely does not matter. Here's what matters. If I have 3 over 4.5, the 3, is that from the smaller or the larger pentagon? I'm just gonna make myself a little note, SN for small. And then the 4.5, that's from the larger, right? And LG for large. So if you did 4.5 over 3, you did the large one over the small one. And either way is fine, but what you have to remember is in your other fraction, you have to keep the relationship the same. So if you did small on top, large on the bottom, then you have to have small on top, large on the bottom over here. If you reversed it and did large on top, small on the bottom, then you have to have large over small on this one as well. Okay, so you just have to be consistent. It absolutely does not matter which way you go. So now to figure out x, okay, here's side x. What's the value on the other side that corresponds to x? 3. Okay, so x is the smaller pentagon, so I'm going to put x in the top. And then 3 is from the larger one. I'm going to put the 3 on the bottom. So if you did 4.5 over 3, if that's how your brain would have worked, is to stack it like that, then you would have put the 3 from the larger one on top, x on the bottom. We will come out with the same answer. I'm not going to go any further with that one, but we will get the same exact answer. Here's how you solve a proportion, any proportion, no matter where you are or how you're applying it. Proportions will come up for us again in this class when we get a little later on. Here's how you solve it. This I don't like to call this what most people do because then it leads students to get confused when multiplying fractions. What we do is we multiply along the diagonals. I'm going to multiply in an X shape right here. Some people call it cross multiplying. Okay, the only reason I object to that is in my algebra class, I asked students how to multiply fractions and they said cross multiply. And that's not how you, when you multiply fractions, you just multiply the tops and multiply the bottoms. Okay, so we're going to multiply along the diagonals. It's a small thing, but it makes me happy. So here we go. 4.5 times x is 4.5 times x. That has to be equal to, when I multiply along the other diagonal, 3 times 3, that is 9. And then my last step is I'm going to divide to figure out what x is. So in your calculator, if you wouldn't mind doing this for me, what is 9 divided by 4.5? 2. There you go. X turns out to be 2. So that's the x side. And so what I'm going to do is I'm going to give you a couple minutes. I want you to figure out what the y side is. Okay, the setup is very similar. We know two sides, and then we need to figure out y. right, so the first thing I'm going to do is I'm going to set up a fraction, a ratio of the two sides I know. So again, I'm going to use 3 over 4.5. Again, I'm not going to go through the whole thing, but if you have it flipped, then your other fraction is going to be flipped. A question I sometimes get is, hey, we already figured out x is 2. Could I use that side with this side to make the fraction 2 over 3? And the answer is yes, you can. Once you already figure out the relationship, you have other options, but I'm just going to stick with the way the problem was given. So if my fraction here is 3 on top for the small pentagon, 4.5 on the bottom for the large one, if I'm going to figure out y, what is my other fraction over here going to be? 4 from the small pentagon, and y is its corresponding side on the large one. Okay, once again, I know it's boring when I repeat myself. If you have 4.5 on top and 3 on the bottom here, then you have y on top and 4 on the bottom here. Okay, so we should get the exact same answer. So now I'll multiply along the diagonals. And so 3 times y is 3y. 4.5 times 4, is that 18? And when I divide both sides by 3, I get that the y value is 6. And so that is the other missing value.
I want something completely different, but that's the same answer.
What did you do? Uh-oh.
Well, I erased it, it was wrong, but I put 2 over 3.
Uh-huh.
There was this x.
Mhm.
And then I did 4 over 1.
Once we know this side, you can totally make that fraction. 2 over 3, you can use that relationship now. The only reason I would say not to, okay, and this is like going into a test, is just on the off chance that you did a little calculation error by accident wrong. That's why I would recommend sticking with the known ones going into the test. But I tend to be, what I do is if you're consistent, if I saw that you used your value from the previous one that was wrong, but you did the next one right, I would give you credit. But you know, just to kind of ensure that you don't have to trust me to notice that. All right, the last little thing is related to similarity. You're almost done. This is nice and relaxing. There's a special type of similarity. It's called congruence. That's called congruent. 2 figures are congruent. It's a special type of similarity. 2 figures are congruent if they have equal angles and also equal sides. So the sides are in a direct proportion, meaning it's a 1-to-1. So they're equal. So while you're writing that down, I'm going to redraw I've got my 1 pentagon here, and instead of drawing something similar, I'm going to draw a congruent pentagon if I'm capable of it. Sort of. Okay, so even though it's not perfect, I'm giving you that these 2 are congruent, the special type of similarity where not only are they in proportion, but everything is equal. And we're just going to fill in the missing values, and hopefully this is a walk in the park. So here we go. If I tell you that these 2 figures are congruent, then what is the value of A prime, B prime going to be? Yep, it's going to be the exact same thing, 4. No calculating to do. That's why congruent figures are fun. Good way to end the day. Oh, I need to tell you, I didn't tell you. I should have told you. Sorry. We'll call this one, we'll call this one 2. How about that? We'll be consistent. Okay, so now I'm giving it away. Good job, Kirkster. If I know that, what is the value of BC going to be? 2. What's the value of Z, this C prime, D prime? What's the value of that side going to be? 3. And then if I know angle E prime, what's angle E over here going to be? Exactly. Congruent figures, not super interesting. It's more about what the idea of congruence is.